Welcome to Lecture 14 of Computer Programming Fundamentals, L14 Class Creation and Execution. Now that we have demonstrated the three families of control structures given computer program code models L13A.Java through L13F.Java, let's further focus on the development of reliable computer programs. Reliable computer programs that not only emphasize structured programming best practices, but extend structured programming best practices by producing modular computer program code that is not only reliable, but is maintainable as well. Computer program code model L14.Java is used to demonstrate this modularity. By organizing computer program code models L14A.Java through L14F.Java into one single computer program code model, namely computer program code model L14.Java. Since we are now using the Java computer programming language to demonstrate modularity, a computer programming language based on the computer programming language object-oriented paradigm, each computer program model L14A.Java through computer program model L14F.Java will be organized as user-defined classes. User-defined classes that will be instantiated and executed by computer program model L14.Java. Here each user-defined class will be in the form of bytecode, that is compiled source code that by itself is not executable until instantiated by computer program model L14.Java, where the execution of the classes takes place, where L14.Java includes an instance of each class L14A through L14F. Here each class file L14A.class through L14F.class includes one of the computer program control structures previously discussed in Lecture 13. That was previously demonstrated by computer program code models L13A.Java through L13F.Java. Thus, each control structure is treated as a separate modular class within computer program code model L14.Java, a separate class that is instantiated from within L14.Java's main method definition, where the execution of the class instance takes place. This isolation of the proven computer program classes, already proven by computer program code models L14A.Java through L14F.Java, are now isolated to improve computer programming code maintainability. Not only are the modules or classes isolated, but they are in object form, bytecode that cannot be altered by those reusing the classes. As such, under the computer programming language object-oriented paradigm, unlike the computer programming language procedure-oriented paradigm, where the modules are in source code form, providing opportunity for altering the code. Thus, under the computer programming language object-oriented paradigm, computer program code reliability is not only improved but secured. This leads to more reliable computer program code for reuse, where reuse is the foremost feature of today's dominant computer programming languages. Dominant computer programming languages based on the computer programming language object-oriented paradigm. I trust this explains the improvement of the reliable computer programming code provided by computer programming languages such as the Java computer programming language, a computer programming language based on the computer programming language object-oriented paradigm. Before the classes representing each of the computer program code models can be executed, that is, the control structures demonstrated by code models L14A.Java through L14F.Java, these classes must first be created. Hence, user-defined classes L14A through L14F must be created. Once the 6 user-defined classes are created, computer program model L14.Java will create an instance of each class and then execute the instance of the class. This is how the Java computer programming language, which is based on the computer programming language object-oriented paradigm, reuses previously proven reliable computer program modules without the fear of altering or harming the already proven computer program code. Okay, next let's look at the process for creating the 6 user-defined classes. User-defined classes that demonstrate structured programming best practices under the computer programming language object-oriented paradigm using the Java computer programming language. I trust you will note the improvement in reuse of computer program code over that of the computer programming language procedure-oriented paradigm, as was discussed using the C computer programming language previously discussed in Lecture 8. Computer Program Model L14A.Java includes the source code for the user-defined class that demonstrates the sequence control structure. Note the absence of a main method definition. This is because user-defined class L14A does not execute any computer program instructions, but merely provides a user-defined class for which another Java computer program will create an instance of that user-defined class, namely in this case the Java computer program model L14.Java that contains the main method definition. The main method definition, which includes the computer program instructions that can create an instance of the user-defined class L14A, and then execute the computer program instructions contained in the user-defined class L14A. As such, for the class creation part, user-defined class L14A is merely compiled to produce the L14A.class file, where Java computer program model L14.Java will use the L14A.class file to create an instance of the user-defined class L14A. More on Java computer program model L14.Java later on in this lecture. Okay, now that we have discussed the coordination between the user-defined class creation part and the user-defined class execution part, let's turn our attention back to L14A.Java. Note as previously mentioned, there is no main method definition, but rather an underlying method definition called RL14A. Namely the computer program code public void RL14A left paren closed right paren left brace system.out.println left paren double quote hello world double quote right paren semicolon right brace. Here there is just one method contained within the user-defined class L14A. The rules already discussed for keywords public and void apply here for the method RL14A, as they do for all method definition headers in general. Here the public member access modifier specifies that RL14A method is accessible by any Java computer program that creates an instance of class L14A. In this case, Java computer program L14.Java. Thus, the single computer instruction included within method definition RL14A, namely system.out.println left paren double quote hello world double quote right paren semicolon, will be executed as we will see later when Java computer program model L14.Java is run. The void keyword specifies that nothing is returned when method RL14A is called or executed in computer program model L14.Java. Finally, the closed parens following the method definition name RL14A indicate that no arguments are passed when RL14A is called. So in closing, for user-defined class creation, classes are merely compiled to provide a asterisk.class file or bytecode that is reused many times by many other computer programs while preserving the originating source code. Because unlike that of the C computer programming language that reuses source code, the Java computer programming language based on the computer programming language object-oriented paradigm reuses object code or bytecode, reuses classes by creating instances of those classes, instances of classes that contain proven methods that can be reused without the risk of altering the original source code. Java Computer Program Model L14.java will demonstrate how to reuse these proven classes. Computer Program Model L14b.java includes the source code for the user-defined class that demonstrates the for-loop control structure. The for-loop control structure is a member of the repetition family of control structures. Everything that we have discussed for the sequence control structure holds for the for-loop control structure, with the exception, as you will note, that the method definition for the for-loop control structure, namely RL14b, rather than as for the case of the sequence control structure, which was RL14a, and the specific computer program instructions included within RL14b method definition, specific computer program instructions that demonstrate the for-loop control structure. Computer Program Model L14c.java includes the source code for the user-defined class that demonstrates the do-while loop control structure. The do-while loop control structure is a member of the repetition family of control structures. Everything that we have discussed for the sequence control structure holds for the do-while loop control structure, with the exception, as you will note, that the method definition for the do-while loop control structure, namely RL14c, rather than as for the case of the sequence control structure, which was RL14a, and the specific computer program instructions included within the RL14c method definition, specific computer program instructions that demonstrate the do-while loop control structure. Computer Program Model L14d.java includes the source code for the user-defined class that demonstrates the while loop control structure. The while loop control structure is a member of the repetition family of control structures. Everything that we have discussed for the sequence control structure holds for the while loop control structure, with the exception, as you will note, that the method definition for the while loop control structure, namely RL14d, rather than as for the case of the sequence control structure, which was RL14a, and the specific computer program instructions included within the RL14d method definition, specific computer program instructions that demonstrate the while loop control structure. Computer Program Model L14e.java includes the source code for the user-defined class that demonstrates the if decision control structure. The if decision control structure is a member of the decision family of control structures. Everything that we have discussed for the sequence control structure holds for the if decision control structure, with the exception, as you will note, that the method definition for the if decision control structure, namely RL14e, rather than as for the case of the sequence control structure, which was RL14a, and the specific computer program instructions included within the RL14e method definition, specific computer program instructions that demonstrate the if decision control structure. Computer Program Model L14f.java includes a source code for the user-defined class that demonstrates the switch decision control structure. The switch decision control structure is a member of the decision family of control structures. Everything that we have discussed for the sequence control structure holds for the switch decision control structure, with the exception, as you will note, that the method definition for the switch decision control structure, namely RL14f, rather than as for the case of the sequence control structure, which was RL14a, and the specific computer program instructions included within the RL14F method definition. Specific computer program instructions that demonstrate the switch decision control structure. Finally, note the source code for computer program model L14.java. The Java computer program model that will execute each of the 6 classes, the 6 classes that represent each of the 6 structured programming control structures, where each class has been previously compiled to produce bytecode. Bytecode or object code that can be reused by Java computer program model L14.java. Here an instance of each class is created and executed. For example, note the following computer program instructions included within L14.java's main method definition, namely L14A, L14AT equal new L14A left paren right paren semicolon, L14AT dot RL14A left paren right paren semicolon. Here the first computer program instruction, L14A, L14AT equal new L14A left paren right paren semicolon, creates an instance of class L14A named L14AT. This is a basic assignment computer program instruction where the result on the right is assigned to the data variable on the left. In this case, the data variable or object L14AT of data type L14A, where L14A just happens to be class L14A. So the new class or object L14AT is of data type L14A. So it inherits the methods and data encapsulated within L14A. As such, L14AT is an instance or mirror image of L14A. Remember, the data type precedes the data variable it types. This is a syntactical rule that originated in the C computer programming language that has carried over to the Java computer programming language. The difference is that under the computer programming language object-oriented paradigm, data types can be of object or class types. Okay, let's examine the right side of this assignment computer program instruction, namely new L14A left paren right paren. Here the new keyword uses a method call of L14A to create a new instance of class L14A. L14A is called a constructor method by computer programming purists because its execution or call along with the new keyword provides a new instance of a class, in this case a new instance of class L14A. Now that the class instance part has been discussed, let's take a look at the execution of the class instance, namely computer program instruction L14AT.RL14A left paren right paren. Here we see your dot syntax indicating that method RL14A is a member of the class L14AT, where L14AT is an instance or mirror of class L14A. Remember method RL14A? The only method definition in Java computer program model L14A.java, or more appropriately, the method underlying class L14A. I trust this explains how user-defined classes are created and then executed. More importantly, how computer program code is reused under the computer programming language object-oriented paradigm. Note, as was the case for class L14A, identical computer program code exists for the remaining 5 classes. As such, I will not repeat myself for classes L14B through L14F. Also note that Java computer program model L14.java has our old familiar main method definition, namely public static void main, left paren string args, left bracket, right paren. Because unlike computer program models L14A.java through L14F.java, computer program model L14.java executes the bytecode. Next, let's take a look at the execution in the next slide. Note here, after compiling and running computer program model L14.java, that the execution of the class instances of user-defined classes L14A through L14F is identical to the individual execution of Java computer program models L13A.java through L13F.java. This will always be true of reuse of classes or bytecode, because under the computer programming language object-oriented paradigm, source code is not exposed, whereas under the computer programming language procedure-oriented paradigm, source code is exposed. I trust Lecture 14 describes the difference between reuse of computer program code under the computer programming language object-oriented paradigm when compared to reuse under the computer programming language procedure-oriented paradigm. For example, compare Lecture 8 with this lecture.